Good evening, everyone. I'm audible now. Great. So yeah, last class, this is I think where we stopped. We were talking about compound interest becoming a certain number of times in a given time period, and then so it was basically double in 7 years. And how many years will it become? 8 times. On similar lines, there is another question that I'd start with today. Look at this question. What is treble? What is treble? Hmm. So the question says, if a sum of money trebles itself in 6 years, in how increased 100%. Treble is becoming 3 times. So the question here says, if a sum of money becomes 3 times into 3 itself in 6 years, in how many years will it increase 2600%? If something is increasing 26%, 2600%, how many times of itself does it become? If we start with P, for example, and increase it 2600%, what will be the final value? No, it will not be 26p. If there is an increase of 2600%, right? So, for example, if the value is p, it increases by 100%. It does not become 1p, it becomes 2p. Yes, absolutely. So, this value into 1 plus 2600 upon 100. So, therefore, if p has to increase 2600%, it will become 26 plus 1, 27p. So, basically, the question says if a sum of money becomes 3 times in 6 years under CI, how become 27 times? And answer? Absolutely. So we know that to make 3, we have to raise the power of 3 by 3. And therefore, I multiply this here, this to 6 to get the answer. Logic being, P becomes 3P in 6 years, right? This 3P will become 3 times, therefore 3 into 3, 9P in another 6 years. And if this 9P had to triple and become 9 3 are 27P, that will take another 6 years. So from P to 27P, the number of years is 6 plus 6 plus 6, or 18 years becomes the answer. This is pretty much where we left in the previous class. There is one rule of thumb that you might want to just note down here. In case of compound interest, it is an empirical formula basically. Never has been asked in CAT as such, but just so that we are aware, in case of compound interest, if a sum becomes twice in n years at r% rate, then we can say that r into n will approximately be equal to 72. This is called the rule of 72. It is an empirical formula, not an exact value, but approximately it will work. Okay. So this question asks us, what is the minimum complete years required so that an amount doubles itself when invested under CI at 10% per annum? You typically use this rule when you are looking at investments and need to have a rough idea of the time that will take or the rate that is required. So, in how many years will a sum of money? Yes, absolutely. Very nice, Aditi. Will a sum of money double itself? So, since the rule of 72 says at CI, for a money to double, R into N has to be 72. Rate is given to be 10 for me, and therefore n has to be approximately 72 by 10, which is 7.2 years. The question says, in how many years will it double itself? So if I look at the time period, year 1, year 2, year 3, year 4, year 5, year 6, and then year 7, has the money doubled here? At this point, it has not doubled. It will double at about 7.2 years. So what is the minimum years required? So I'm sure that I will have double the money. For example, if I'm starting from 100 rupees, it becomes 200 at this point. Here it would have been 190 something. And therefore, to have a money which is at least double, I will have to wait waiting the entire year. I'll have to wait for 8 years, and 8 becomes the answer here. While practicing, you might come across a question here and there which is based on the rule of 72, and therefore mentioning it. The important point for today's class is comparison of SICI, and on this there have been questions asked in lots of examinations. So basically, if you look at simple interest, compound interest, assuming that the principal invested is rupees P, rate is R%, right? What I want you to do is figure out the difference between SICI for every year. So SICI for every year 1, year 2, year 3, and so on. These are the numbers that we are trying to figure out. To make things easier, what we can do is we can take the principal say as 10,000 rupees and the rate say as 10%. We get simple interest and compound interest for year 1, year 2, year 3. So I'll do the starting calculation. Simple interest for the first year will be 1,000 rupees. Simple interest, compound interest for the first year will also be 1,000. Basically, interest in both cases will be P into R upon 100. Is this okay? And therefore, I can say simple interest for year 1 is equal to simple interest for year 2. Again, we knew this. What happens for the second year? Second year, can I say simple interest will still remain 1,000 rupees? What will be the compound interest for the second year? What will be the compound interest for the second year for the given number? 1,100. So now this 1,100, what I will get 10% on the principal, hence 1,000 rupees. Plus, I will get 10% on this 1,000 as well, therefore an extra 100 rupees. Does this make sense? Because in compound interest, we get interest on interest. In the second year, we will get interest on the principal plus interest on the interest that is accrued. And therefore, if I look at this in terms of PNR, the interest, simple interest will be PR upon 100. Compound interest will be PR upon 100 plus R% of this. What will be R% of this? R% of PR upon 100 will be R upon 100 into PR upon 100, which is nothing but PR squared upon 100 squared. So what is the difference between CI for 2 years? This part here becomes the difference between SI and CI for 2 years. And therefore, I can simply say difference between SI and CI for 2 years is PR square upon 100 squared, right? Here it should be noted that difference for 2 years and difference for the second year, both will be same values. Difference for 2 years, year 1 and year 2, and difference for the second year, both will be same values because in the first year, as it is, the difference was 0. What will be the simple interest, compound interest for the third year? Simple interest, I am saying it will be 1,000 rupees, no problem with that. What about the compound interest for the third year? So what I'm saying is, on the principal, we'll get 10%, so 1,000 rupees for that. On this 100, on this 1,000, we will get 100 rupees, 10%. On this 1,000, we will get 100. So again 100. And on this 10, we will get, it is 10. So on these 2,000s, I get 100 rupees as the interest. And on this 100, I get 10 rupees as the interest. And therefore, in the third year, this becomes the difference. If I'm trying to write it down in terms of PNR, the principal, we get PR upon 100. On these two values, when we calculate R%, we get PR squared upon 100 squared. And if we calculate R% of this, we'll get PR. So this is twice of that. One for here, one for here. And from here, we'll get PR cube upon 100 cube. R% of PR square upon 100 squared, right? So this is how the calculation happens. But for us, what is important to understand is, yes, I'll do that. So uh, starting from a fresh slate, SI, CI, year 1, year 2, year 3. This will always remain PR upon 100. No changes here. In case of compound interest, what I'm saying is, I will keep getting PR upon 100 on the principal, where there will be no change. But from second year onwards, we will get interest on whatever interest is accrued. So for the second year, I calculated R% of this. R upon 100 into this will give me PR squared upon 100 squared. Now, when we look at the third year, we get this on the principal, because the values written above this row are also the accrued interest. So I'll get interest on that as well. What will be the interest on this value and this value? R% of PR upon 100. And this is there 2 times. So R upon 100 into PR upon 100 into 2. Therefore, 2 PR upon 100 squared. Plus, I need interest on this part as well. And therefore, R% of PR squared upon 100 squared will be R upon 100 into PR squared upon 100 squared, which is nothing but PR cube upon 100 cube. Alright, ma'am. This is how the calculation happens. So, what is the formula that we will get? Can I erase this, ma'am? So, this is the difference for the third year. And therefore, the formulas that we get are, difference between CI and SI for the first year is 0. For the second year, it is PR squared upon 100 square. For the third year, CI minus third year SI, it is 2 PR squared upon 100 squared plus PR cube upon 100 cube, right? And for 3 years, year 1, 2, 3, the difference will be the sum of these two, and therefore this is the formula that we get: PR cube upon 100 cube plus 3 PR square upon 100 squared. These two things get added for the third year for 3 years. More often than not, questions that have been asked have been for the difference of 2 years. Maybe 2 times there has been a question based on the difference of 3 years as well. All right. Just let us look at a few questions on this concept. Again, the table that I made, you can solve questions using that table, questions using the formula. Depending on the data given, one or the other approach might be useful. For example, look at this question. Difference between CISI, 5,000 rupees, 2 years, 8% per annum. Any answer? 320, 32. Okay. So we have to find out difference between CI and SI for 2 years. I can simply put in the formula here. Difference between CI and SI for 2 years is PR square upon 100 squared, which is P 5,000 into R square, 8 into 8 upon 100 into 100. 0, 0, 0, 0 gone. 50 upon 100 is 2, 2 fours are 8, and therefore 8 fours are 32 becomes the answer. If I was making a pairing SICI, year 1, year 2, in the first year, interest will be 8% of 5,000. 8% of 5,000 will be 400 rupees. So 400 here, 400 here. Second year, interest will remain the same, simple interest. Compound interest will be 400 on the principal plus 8% on this. 8% of 400 is nothing but 32. And therefore, the difference will come out to 32 rupees. But again, here because P and R were outrightly mentioned, just putting in the formula, I think makes more sense. Answer 32. Look at this question. A certain sum of money invested in the SICI, both at the same rate of interest 5% compounded annually. Principal is to be found if the difference is 100 rupees for 2 years. 2020. Any answers? Very nice. Hmm. Again, since the difference and the rate is mentioned, we have to find out P. It is just a matter of putting in the formula and plugging in values, and that will give us the answer. So here what I'm saying is the difference between CI and SI is given by PR squared upon for 2 years. The difference is 100. You have to find the principal rate is 5. This is not an S, this is a 5. 520, 5, 4, and therefore P becomes 4 into 100 into 1,000 rupees. Right? Correct. If I was comparing SI and CI, so you have to understand here, if the simple interest for the first year is X, the second year it will be X, compound interest will be X, and in the second year it will be X plus 100 the difference. Why do we get this 100? Because it is principal, it is the interest on X that we are getting, and therefore I can say 5% of X is equal to 100, or 5 by 100 into X is equal to 100, which will give me X as 2000 rupees. This means the interest for the first year is 2000. And how do we get this 2000? That is 5% of the principal. And therefore we can say 5% P is equal to 2000. 5% is 1 by 20 into P is 2000, and therefore P will come out to 40,000 rupees. A question where, again, this is a direct formula. Okay, this is a 3-year difference. Look at this question. Sorry. Any other? Hmm. So again, just putting in the formula, we can say difference between CI and SI for 3 years can be written as PR cube upon 100 cube plus 3 PR upon 100 squared. This becomes P, principal 1600 into R, 5 into 5 into 5 upon 100 into 100 to 100 plus 3 P, P 1600 R squared sorry, plus 3 into r p into r squared, 5 into 5 upon 100 into 100. 0, 0, 0 to cancel. 5 20s are 5 20s are 5 4s are 4 4s are. Uh, I have made some mistake. I'm just 0, 0, 5 20s are 100. 5 4s are 24. From here we'll get 0, 0, 0 cancel. 5 20 5 4. This will give me 12. Zero. Yes, this was 1. 1 by 5. From here we get 0.12.2. Okay. Forgot to cross out the 5. Anyways, what if we compare SI and CI and make a table for here? If I'm comparing SI and CI for 3 years, again, I'm doing this just to show you that there is another method of calculating CI. Simple interest, 5% on 1600 will be 80 rupees, right? 10% 160. Yeah. So simple interest will be 80, 80, 80. Compound interest will be 80. Here it will be 80 plus 5% of 80, which will be 4 rupees. Third year it will be 80 plus 5% of this plus 5% of this, which is 4, and plus 5% of this, which is 0. And therefore the total difference will be 4 plus 4 plus 4, 12 plus 0.2, which is 12.2. Right? Great. Let us look at another question, and then we'll move on. This is okay. We look at this question. Hmm. Perfect. So it says an amount in by 48% when invested for 6 years at simple interest. Now, if 6 years, the overall rate, sorry, if for 6 years the overall rate is 48% simple interest, we can say that the yearly rate for simple interest will be 48 upon 6, which is 8% per year per annum. Now, if we have this rate on compound interest, the principal will increase twice by the same rate, and therefore the effective will be 8 plus 8 plus 8 into 8 upon 100, which is 16.64%. So basically, in simple interest, we add the rates. In compound interest, we use successive percentage formula. Okay, now this is a question. This is one question where you might the difference here be there. Hmm. Just a second. Okay, look at this question 36, 90, 40%. Hmm. Again, we can just put in the formula here and then solve. So it says CI for 2 years is 216, simple interest uh, uh, at the same rate on the same principal is 180, right? We have to find out the rate. So the difference between CI and SI here will be 260 minus 180. We have to find out the rate. The principal is not given. So we write P into R square upon 100 squared. Therefore, 36 is equal to, oh, okay, very nice. P into R square upon 100 squared. And then we need another formula because there are two variables, principal and rate both are missing. So where do we get the second formula? The second formula will become the formula for simple interest. Simple interest for 2 years is P into R into 2 upon 100. Simple interest is given as 180. And therefore, P into R into 2 upon 100 is 180. So from here, we get one equation in P and R. Here we get another equation P and R. We can solve the two equations to get the answer. But as I was saying, in this case, probably comparing SICI will be a better option. For example, if I say SICI for 2 years, year one and year two, all right? What will be the simple interest for each year? Hmm? Simple interest remains the same. It has to be 90 and 90, equally divided. What about the compound interest? In the first year, compound interest will be same. So what is the compound interest in the second year? Total compound interest was 216, out of which 90 was in the first year, therefore 126. And this 126 I can again split. One part of it has to be 90, the interest on the principal. What will be the remaining part or the extra part? The extra part will be 36. And therefore we can say that this 36 is interest on this interest. 36 interest is because we got interest of 90 rupees in the first year, and therefore R percent of 90 is equal to 36. And this directly gives me the answer. 0.094 36 to 40%. So when values are missing out of the difference PNR, when PNR both the values are missing, it might make more sense to compare the values in SICA and solve. If two out of the three values are there, then it makes more sense to simply plug in the values in the formula and solve the question. Look at this question. Ratio of simple interest on a certain money for 2 years and compound interest on the same money for 2 years at a rate of 5% is. Hmm. 40 and 41, all right. We have one answer. Hmm. Okay, 40, 41. Very nice. So what I'm doing here is 5% rate. So we have to compare SICI for 2 years. One is you take the principal as 100 and then find the interest. So for the first case, it will be 105. Simple interest and compound interest can be found out. Better approach here would be, I suppose, assume the interest for the first year to be 100, simple interest. Second year, it will be same. First year, compound interest will be the same. In the second year, compound interest will be 100 plus 5% of this, which is 5. Hence, the ratio simply becomes 200. And this is 205. Therefore, 200 upon 205 divided by 5 becomes 40. Assuming the fact that interest may not be paid yearly. We can calculate interest earlier as well. For example, I mean, if you look at bank account statements, you will realize that your bank account gets an entry of interest every 3 months, every 4 months, depending on the bank that you have in account with, right? Also, if I look at, say, a payment that I have to make a loan that I took, I may not pay it on a yearly basis. For example, if I buy a phone, I might actually have a 6 month EMI. The loan might not actually reach the year, and therefore compounding has to happen more frequently than a year. Now, what changes will happen in that case? For example, suppose if I say that interest, compound interest, is being calculated half yearly. What does this mean? We will calculate interest 2 times in a year. The data that we had to have is principal was 1,000 rupees, rate was 20%, and time was 1 year. Now, how will the interest be calculated in this case? Interest has to be calculated half yearly. So, what I'll have to do is on this 1,000 rupees, I'll make the first calculation after 6 months, right? So, what needs to change for this calculation to happen? What will be the rate for this calculation? Now, whatever rate is mentioned is for a year always, but we are charging interest in half years, and therefore the effective rate will become half of R, right? And therefore we'll calculate the interest at 10%. Since half yearly the interest is being calculated, therefore we will calculate interest again after 6 months. The process will remain same. On 1,000 we will have 10%, so this amount will become 1,100 rupees. Then again 10% rate, R by 2, and therefore this will become 1,210 rupees finally, right? So what are the two things that changed? If I have to write the formula for this case, where I say amount is equal to principal into 1 plus R upon 100, what has changed? The principal did not change. We calculated the interest on the principal to start with. But instead of rate of 20%, we took R by 2 because we were calculating interest twice. Also, typically, here we should have a value of 1. But since compound interest is being calculated yearly, instead of 1, what will be the value or what will be the value of the power? It will become 2 times of t because half yearly calculation is happening. So the number of times we are compounding, we divide the rate by that value and multiply time by that value, right? For example, if I say CI quarterly, what does my formula now become? Amount is equal to P into 1 plus. Now, if it is happening quarterly, that means in a year, how many times will the interest be calculated? Since it is being calculated quarter 4 times, and therefore we multiply this by 4. So if hmm, so basically what I'm saying is, if CI is being calculated n times in a year, the formula will become amount is equal to P into 1 plus R by N upon 100 raised to power N into T. This okay, man? Is this okay, man? Great. Now tell me, uh, we calculate compound interest yearly versus calculate compound interest half yearly, does the interest payable change? Does the overall interest payable change? Sorry. Hmm? Of course, it will change. If we were calculating compound interest in this case on this data for a year, the interest would have been 20% of 1,000 simply, which is 2,000 rupees. But in this case, what happens? The interest comes out to 210 rupees. Since there was that got added 6 months, the next part of the interest will calculate extra interest on this added part as well, right? Can you tell me the effective rate for the half yearly interest? If compound interest is being calculated half yearly, what will be the effective rate for the year? What becomes the effective rate? Hmm. One guys, the effective rate will be 21%. 21, 210 on 1,000 rupees. How do we get it? When I say half yearly interest or interest two times over, the 20% get breaks down into 10%. Therefore, instead of 20%, our effective rate will become 10 plus 10 plus 10 into 10 upon 100, which will be 21%, right? So, can I take this further and say that the more frequenting the compounding happens, interest will have to be paid? Is that something that I can say? If the compounding happens yearly, the interest payable will be lower. If it happens half yearly, it will be higher. If it happens quarterly, it will be still higher, and so on. Right? What if I ask you? What if I ask you that interest is being calculated monthly? Then what will be the interest payable? R by 12 and 12 into T. This will be the amount after 1 year. Do you know where monthly interest is calculated? Where do we calculate monthly interest? Banks. Actually, banks don't calculate monthly interest, though we call it EMI, equated monthly installment. But in real life, what happens is continuous compounding, not something that has been asked in the exam or is part of a syllabus. But when you take a loan, banks do continuous compounding. The formula that they use is A is equal to P into E raised to power RT. So basically, compounding happens at every second in a way to understand it, right? Since there has to be a time that you'll pay, it's calculated for a month and then we get the answer. Okay, so when we talk of compound interest, the interest changes. What happens when simple interest is being calculated? What if I calculate simple interest half yearly? Because what happens is some of the banks, what they do is they say, we'll pay you interest 4 times instead of 3 times. We'll pay you interest. Some banks pay every 6 months. So how does that change? What is the change of simple interest? Suppose if I say principal is 10,000 rupees, rate is 20%, and we are calculating interest, but simple interest is being calculated half yearly. What will be the overall interest in this case? What will be the overall interest calculated in this case? 21. Okay. Let's see. 1,000 rupees. For the first 6 months, what will be the interest? 10% because rate is 2. So for 6 months, rate will be 10, 20 by 2, which is 10. So interest will be 100 rupees. What happens for the next 6 months? In simple interest, we calculate interest on principal. So again, 10% of 1,000, so another 100 rupees. So what is the total interest? It will still remain 200 rupees. See, if you look at the formula for simple interest and you make the changes like compound interest, principal will remain as it is. R will get divided by 2, T will get multiplied by 2. This 2 and 2 cancel. So in case of simple interest, it does not matter when you pay interest. Overall, it will always be the same. The change happens only in compound interest, right? Uh, so if you can help me solve not this one, but this question, which of the following schemes are best? Please note the rates are changing, and therefore, otherwise, what will always happen is SI for 2 years will be less than CI for 2 years if the rate is same, and more frequent CI will be more than annual CI if the rate is same. Here the rates are different. So what you have to do is you have to tell me which of the schemes are best in terms of investment if you are going to get money out of these schemes. Hmm. Which scheme is the best? In scheme one, it says, which of the in scheme one, it says investment 20% per annum for SI 2 years. So what will be the effective rate in scheme one for 2 years? Effective rate for scheme one in 2 years will be how much? What it will become 40%. What will be the effective rate in scheme two for 2 years? Here investment is 18% per annum CI for 2 years compounded annually. So can I say that the effective rate 18 plus 18 into 18 upon 100, right? So this becomes 36. 18 into 18 is 324, so 3.24. Therefore, 39.24%. Because this rate was lesser, therefore, in our case, scheme 1 seems to be better than scheme 2. How scheme 2 and scheme 3? Scheme 2 is 18% per annum CI for 2 years. Scheme 3 is 16% annum CI for 2 years, compounded semi-annually or half yearly. So for scheme 2, 1 year effective rate percent. What will be the effective rate for scheme 3 for 1 year? What will be the effective rate for scheme 3 for 1 year? Hmm, absolutely. So here what I can say is because the rate is 16% per annum and it is being calculated semi-annually, that means the effective rates for each of 6 months will be 8% and 8%. Hence, the overall rate will be 8 plus 8 plus 8 into 8 upon 100. So this will become 16 plus 64 upon 100 or 16.64%. See, if we compare these two, 18 is more than 16.64. So in this case, scheme one will give a better return than scheme 2, will get a better return than scheme 3 for the simple reason that the rates were higher for scheme 1 than scheme 2, and further for scheme 3, the rate was lesser than scheme 2, right? But this is how we can calculate effective rates and compare different schemes, right? One last topic that I'm just touching for today is the concept of installment. How do installments play out? See, if I say that I take a loan, say I'm trying to buy a phone. So I'm taking out a loan of rupees 80,000, for example. And the down payment I'm doing for the loan is, say, 20,000. What we have decided is pay rupees X every year as part of the payment, and the rate that is going on is 10%. My question is, what is the amount that I should pay every year, assuming that I am taking this loan for 3 years? Of course, this is happening at compound interest. Now, just follow me with the calculations here. There are different ways of looking at it. One way could be that we look at the exact process that happens. So in year zero, when the thing starts, what is the loan that I've effectively taken? The phone was for 80,000 rupees. I paid 20. Basically, I've taken a loan of 60,000 rupees. What will the year of end of year one? Since the rate is 10%, can we say this will become 66,000 rupees payable? At this point, I pay rupees X. So the amount due is 66,000 in minus X. What happens at the end of year? Can I say 1,000 minus X will again increase 10%. And at this point, I pay another X rupees. What happens at year three and end of year three? This entire thing further increases by 10%. So here the amount payable will be 66,000 minus X into 1.1 minus X. This was not needed. Into 1.1. So this entire thing has increased by 1.1%, by 10%, therefore multiplying by 1.1. Can I say that this should be equal to my last installment so that the loan clears out? We get a equation in X we can solve. So this is called reducing balance. Reducing balance, right? What is happening is we increase the principal by 10% or R% every year, and then take out the EMI that, or the yearly payment that we are doing for the loan. For the remaining amount, we again increase by R% and follow the process. The other way of looking at this could be equating the money payable at the end of time, right? What does that mean? That means I took a loan of 60,000 at the start of year zero, right? What will be the value of this money at the end of 3 years? At the end of 3, value of this money, because compound interest will be charged for 3 years, it will become 60,000 into 1.1 raised to power 3. How am I repaying this? At the end of year 1, I pay rupees X. At the end of year 3, the value of this will be X into 1.1 raised to power 2. After year 2, I pay X rupees. So the value of this X rupees at the end of 3 years, that is after 1 year, will become X into 1.1. And finally, at the end of the third year, I'm paying X. The value of this will be X. And therefore, I can equate these two and say 60,000 into 1.1 cube, the amount payable is paid using X into 1.1 square plus X.1 plus X. Again, in equation X, we can solve this. The previous equation and this equation will be exactly the same when rearranged, right? So this what I'm doing here is I am uh, equating the future values of the amount of money that we have. Is this okay? If this is okay, then the last part that I want to use here is, see, if I have 100 rupees today and the rate is 10%, the value of this 100 rupees becomes 100 into 1 plus 10 upon 100 after 1 year. What if I want to do the reverse? So if you pay me 100 rupees today, effectively I will have 110 rupees after 1 year. What if I say that I will give you 220 rupees 1 year later. What will be the value of this money today? If I sell pay you 220 rupees 1 year later, what should be the effective payment today to counter the make the payment equal? When we are projecting the money forward, we multiply by this. If we have to project the money backward to find the present value rather than the future value, we divide by the multiplying factor. For example, if I say x rupees today is equal to 220 rupees in the future, that means x into 1 plus r upon 100 be equal to 220, which means x is nothing but 220 to 1 plus r upon 100. Right? So in the case of the payment that we are making in case of installment, what we can say is we have to pay 60,000 rupees today. 60,000 is payable today. It is being done with 3 equal installment of x rupees over the 3 years. What will be the value of these 3 installments? The installment after the first year, the present will be x upon 1 upon x upon 1 plus r upon 100. The payment that is done after 2 years. So because I'm taking this back 1 year, I divide by 1 plus r upon 100. The payment after second year will have a present value of 100 raised to power 2. Payment after third year will have a present value of 1 plus r upon 100 raised to power 3. Since r is 10, the formula that we'll get is 60,000 is equal to x upon 1.1 plus x upon 1.1 squared plus x upon 1.1 cube. Again, this formula and the two previous ones that we wrote can be rearranged to give you the same expression. The idea is when you're looking at installments, you would want to equate cash flows at one point in time. We can do that at the end of time. We can do it at the start of time. If we are taking money forward, we multiply by the multiplying factor. If we are taking money backwards, we divide by the multiplying factor. And one method of it is that you reduce the value. So you do the entire process step by step to see the final payment and equate it to the final installment. We'll take up questions on this in the next class. So the idea should become clearer. For now, this is all I. So yeah, in terms of theory, this is what we have to cover in SICI. Next class, I think it is on Sunday. We'll be doing questions. We'll share it hopefully by tomorrow. Make sure we attempt those questions and do that. Again, as I said, in terms of importance of this topic, invariably is the wrong word. I think every year there is every paper in CAT there is one question from SICI. The focus seems to be CI, but or a comparison between SI and CI. Pure SI questions have been rare, but again they are very doable in the sense if you understand the concept of what is happening. This is a question that you will invariably be able to solve in the exam, right? So yeah, that is what I had for today. Thank you very much. Do make sure you go through the recordings if need be, because compound interest, understanding the concept might take a little bit of time. Is done. You have one question, right? For CAT. Okay, chale. Thank you very much. If there are any questions, I'll be happy to answer. Otherwise, let's call it a night then. Great. Thank you. Good night. I'll see you on Sunday.